Tonight we're talking about, like we mentioned, immune system busters, habits that hurt. And by knowing about these things that can inhibit our immune system, it'll enable us to decrease that impact that they have in our lives by limiting our contact with things that harm our immune system.
And we are not giving formal medical advice. You can, if you have questions about medical healthcare issues, please feel free to contact your healthcare provider as it pertains to you. But the information, I think, will be helpful for everybody.
Mhm. So our learning objectives are fairly simple. We're going to understand the difference between modifiable and unmodifiable risk factors and how it impacts disease in general, disease risk. And then we'll specifically learn about different lifestyle factors that inhibit our natural defenses in various aspects of our lives. So we'll touch on that. Lifestyle shapes immunity. And if you don't believe me now, I think you will by the end of this lecture, or at least by the second lecture. It is very significant. Not only does lifestyle shape immunity, but it also shapes general overall health. And the things that we choose to do day in and day out can make an impact on our health in general today as well as in the future.
As always, everything is a balance of risks and benefits. So that's how we look at pretty much all our lifestyle choices and things that we do, risks versus benefits. Making consistent choices in a positive way for our lifestyle certainly will decrease certain disease risks. But again, nothing is guaranteed for sure. People could live the healthiest lifestyle and still develop cancer or still have some genetic propensity to develop heart disease, etc. I remember one of the most prolific runners who just used to run, and died of a sudden heart attack, and everyone was shocked. But it can happen. You can still live healthy lifestyles and still get diseases. Some various risk factors when we're thinking about our immune system. There are unmodifiable risk factors. So as we age, our immune system becomes less efficient. Also genetics and other biological factors, family history, that's part of genetics. Certain diseases can affect our risk factors for underfunctioning or overfunctioning immune system, and also some ethnic backgrounds and ancestry. So again, that goes with family history and genetics. But there are some modifiable ones, some ones that we can make an impact, some lifestyle choices, some environmental exposures can be modified, use of various harmful substances and nutrition, activity level. There are diseases that we can get, but those diseases are modifiable because some of the most prominent diseases, especially in our country, are all lifestyle related. And so those all can be affected and modified. Our thoughts also are modifiable in choices and behaviors. So those are some modifiable things. Anya, what suppresses our immune system? There are some things that can do that.
Yeah, there's a lot. So we will not touch too much on the unmodifiable risk factors because generally we can't modify them. But I do want to talk a little bit about aging. Like we mentioned, it is unmodifiable. As we age, we see a decline in our immune system function. It's just what happens. The thymus shrinks. And if you attended our first class, you'll remember that the thymus is responsible for producing T cells, which is especially important in adaptive immunity and specifically combating viral infections. There's also a natural increase in yellow bone marrow. Yellow bone marrow stores fat, and red bone marrow, which you have more of when you're younger, generally produces most of your white blood cells, your immune cells, platelets, and red blood cells. So as you age, you have a natural decline in your tissue that naturally produces those functions that aid in support a general healthy immune system. So there's a decline there. That goes along with the general decrease in immune cell numbers. And as we age, function decreases as well. Different underlying medical conditions that we can get because we're more susceptible to them as we're aging can also increase our risk for immune related diseases. And this is just a quick slide on aging and how a few of the different immune cells react to it. We won't go too much in detail, but you can see that in general, most of the function declines with age. You can see in the upper, I think it's right, natural killer cells increase in numbers, but you can see that their function declines.
the certain diseases that can affect our immune system. This is just probably a summary of some of the more prominent ones of which we're aware of. So HIV and AIDS obviously is an immune deficiency disease. There are autoimmune conditions and conditions like asthma, which are hyperfunctioning immune diseases. So we talked about a hyperfunctioning immune system isn't necessarily a good thing. That's also disease, and balance in the immune function, proper balance is what we're searching for. Certain cancers also can lead to decreased immune function, especially those that affect the bone marrow, like leukemias and some infiltrative diseases that affect the bone marrow cells. Also, some medical treatments. So, cancer treatments, certain medications for monitoring and modifying autoimmune conditions like rheumatoid arthritis and lupus and things like that. The medications we give to turn those down and to regulate those overactive diseases will impede and impair the immune function. Bone marrow transplants obviously is an immune hypofunctioning disease. So a number of diseases where the immune function is affected. So let's talk a little bit about stress. So this is a thing that actually can affect your immune function. So we're looking at immune busters, things that turn the immune system down. So stress, we all experience stress in our life at various times, but the key here is too much and for too long. And I know probably many of us have experienced at various times in our life where we feel overwhelmed and have been faced with multiple situations in our life, one stressor after another, and it can become overwhelming. And so this can affect our immune system. In the 1980s, this doesn't mean that the 1980s were stressful, although if you lived through the 1980s like I did, they might have been stressful. But this study was done in the 1980s and studied cellular immunity in 34 medical students. And so I would say medical school in general is somewhat stressful. And they looked at the stress of testing on the students and found that under times of stress, there was a significant decrease in circulating immune cells, T cells, and natural killer cells. And those are two markers that are often looked at in these types of studies. They don't actually look at, did more people get infections or anything like that. They were just looking at the cell number, circulating cell number in this case, and they found that in fact stress decreased these numbers. And then where the opposite happened during periods of relaxation, there was a significant predictor that the immune cell percentages would improve and increase. In a number of studies looking between 1980 and 2004, they did what's called a meta-analysis, which basically means they looked at all these research papers looking at this basic idea, and they tried to compile the statistical data in a way to ask if there was statistical significant changes. So it's kind of a broad way of looking at multiple studies and putting them together in a fairly systematic way to give some information. And so with short periods of stress, they found that there was actually an increase in immune response with your immune cells, which you would then predict as a positive thing, kind of a fight or flight type of situation where you're hyper functioning in a way to be ready for your first responders and all of that. But long-term stress, which ranged from a few days to years, significantly suppressed all aspects of the immune system function.
Generally, they found that older folks or people that were already sick were more susceptible to the negative effects of having a suppressed immune function because they're already at a disadvantage due to health conditions or age.
Okay, so that wasn't a surprise. And then 2009, another meta-analysis looking at 22 papers. They reviewed these and looked at the effect of stress on wound healing. So wound healing would be basically the idea your immune cells jumping in to fix something that needs to be. So all of your white cells working the way they're supposed to be, and your macrophages working the way they're supposed to be. And these were all cells that we talked about in our immune system that are important. And they found, looking at these 22 papers, that stress impaired the healing and the regulation of wound healing. So it slowed down wound healing, and there was dysregulation of all the biomarkers and things that were supposed to be present during wound healing. So bottom line, prolonged stress does actually impact our immune system and suppresses it. Some areas of ongoing study, chronic stress actually causes epigenetic changes. So basically, what that word epigenetic changes means is there are proteins and various configurations of our DNA that affects how genes are expressed, to what degree, or whether they're turned off or turned on. So stress actually affected the way our DNA was actually regulated and expressed at the what we call epigenetic level, leading to inflammation and oxidative stress on our bodies, and which cause telomeres, shortening of measurement in the DNA that is associated with increased aging and advanced aging. So as we age, our telomeres shorten. So we think telomere shortening is a bad thing. And what they found is with chronic stress, there was actually epigenetic changes and telomere shortening, which means kind of progressive aging, accelerating aging.
Mm-hmm.
You mean you're older than you really are? Something like that. But so stress shortens the telomere length. They also saw this in fish. So they did some studies similar to this in fish. And again, they looking at acute stress, it's beneficial, but chronic stress suppresses the immunity and leads to premature aging. You've heard people say, man, you're giving me so much gray hair. So maybe that has something to do with stress. That's kind of what that phrase comes from. The long-term activation of the stress response system with stress and the overexposure of cortisol and other stress hormones is the thing that actually is disrupting these. So we think this is probably the underlying driving factor that's causing some of these things. That was from the Mayo Clinic in 2019. So the answer, so in an acronym, Restore Life, R, rest, relaxation, is super, super important. So like the medical students, your immune system is actually preserved and maintained in a better function if we are looking for balance in our life and not pushing things too far. I don't think it's by coincidence that even in biblical literature, embedded in the law of Moses is a command for rest. 6 days you shall labor and do all your rest, but the seventh is the Sabbath. There was programmed in that literature, in the Bible, is this call to rest, which was recognized.
State of mind, emotions, and thoughts, and how it plays a role in our immune system function. It's something that I initially didn't think had too much of an impact, but some of the studies do show that it does have an impact. And the first thing might come to mind is depression. Depression, this study they did in 2002, they had several participants in the early 70s who were caring for someone with Alzheimer's, and they found that chronic mild depression, individuals suffering from that had a weaker T cell response to viral and bacterial invasions. It's interesting enough, they also found that the suppression even remained 18 months later. So it has long-term effects. We read this already, but as age increases, immunity decreases for different factors that we talked about physiologically. This makes sense. And I want you to take away that subclinical chronic mild depression seems to suppress the immune system of older individuals, and the duration is the key factor, not severity. So again, kind of with stress, it's the length of time, not necessarily the severity of the depression. So even if it's mild, still something to look into and take care of so that we can have healthy immune system function. Negative emotions also were found to have a negative impact on immune system function. We have a list of different ones, but I'm sure this is not all inclusive. Some negative emotions would include frustration, sadness, doubt, despair, envy, guilt, depression, grief, fear, among others. And it's associated negatively with immune function. It depresses your immune cells' ability to work properly. And because of that, it increases your risk for infection. They did a study on rumination, and they found that it negatively impacts immunity.
What's rumination?
Rumination.
Is that like chewing things or
It's
digestion?
like thinking things over and over again in your mind, replaying things over and over again in your mind. So that mentality and that way of thinking has a negative effect on your immune system.
Oh,
And they did a study in young and old, and it didn't really affect young people as much. And you could see the effects more in the elderly, which would mean they might be more susceptible just due to physiologic conditions. But still, it has negative impacts, and it's probably not healthy for young people to do it either. They also found that anger and anxiety compromises the immune system. The list of things that they found that it's general overall hazardous to your health. It increases vulnerability to illness, compromises the immune system, increases lipid levels in your bloodstream, exacerbates pain, and increases risk from cardiovascular disease and all other sources of death. So emotions and thoughts do play a role in our immune system. Next, unhealthy emotional suppression. They don't have too many studies on this. So the one study I did find was done in 1998. And they were looking at the suppression of thoughts, but particularly thoughts that cause negative emotions. Participants were instructed to write down emotional or non-emotional events, and then they would choose whether or not to suppress the negative emotions that would come with that. And they found that emotional writing increased circulation of lymphocytes, so letting out your emotions via journaling kind of enhanced your immune system in that way. While thought suppression, meaning not dealing with certain emotions or trying to avoid things that are negative, things that you might have to deal with internally, tended to decrease T cell lymphocyte circulation.
would that fall under our acronym own it, kind of like being honest with things?
Yeah, especially with our emotions and mental health. I think it's important for us to be honest with ourselves, because when we're truly honest with ourselves, even if it's unpleasant in the beginning, it is the beginning of going to a better place. Poor social connections also had a negative impact on immune cell function. They did a study in 2005 specifically on college students, and they found that social isolation and feelings of loneliness were independent factors that weakened immunity. They basically tested this by giving the students vaccinations and seeing how their antibody response was afterwards. And they found that being lonely and having a small social circle caused the greatest amount of suppression and least likely to develop an antibody response to a vaccination. So maintaining healthy social connections is important, which is a little bit more difficult nowadays, but is nonetheless important.
Okay, here's another immune buster, physical inactivity. How about that? Looking comfortable on the couch there with their phone. That looks like a familiar position. So anyway, so there's been some human studies looking at this. A lot of the studies don't look at inactivity, they look at activity. So we're going to cover some more of that tomorrow because that's an immune booster. But just thinking of it from the negative standpoint, is there any evidence that if you're inactive, that your immune function is depleted? So physical activity is definitely associated with accumulation of adipose tissue or weight or fat, and muscle gets weaker. So you lose muscle and you gain fat. When we're less active, we have increased systemic inflammation that goes along with the adipose accumulation. And they found that there is impaired natural killer cell activity and T cell proliferation. Again, these are two markers, kind of biomarkers that they look at for immune function, and also reduced cytokine production. Again, a cytokine is a chemical signal produced by your inflammatory cells so that you remember your immune system and all the cells and all the communication, that's all cytokines that cause those types of things to happen. There was an animal study, and these involved rodents, and they hung these rodents up by the tail so they were weightless. And they were doing this for astronauts to say, what is the effect of inactivity or weightlessness on our immune system? And so the rats had alteration of white cell differentiation, so they didn't divide and become to their proper types of inflammatory cells as well. And their ability to activate was also impaired. And they also was a failure for these rodents to develop a memory response. So if they saw an antigen, they were less likely to develop their memory T cells and memory B cells, which you remember that was your special ops unit of your immune system to come if you see an infection a second time. can you get too much exercise? Can this impair us? And the answer is absolutely you can, but too much exercise would be basically defined by marathon racing. So there, marathon racing is an immune buster. You guys are all given a pass. No marathon racing is necessary. But every other type of physical activity that is in the normal range of what most of us might actually participate in, like walking and other things, all boost all these various things in these different measures that they have about macrophage function and granulocytes and cytokines and all these different things. So yes, lack of activity is an immune buster, and marathon racing is an immune buster. So I don't want to see you guys joining too many marathons. Once in a lifetime is enough, I think.
Now we're going to talk about good old nicotine. Good old nicotine. In 1998, they did a study and it showed that nicotine impacted all aspects of immunity, humoral and cellular. Recent studies have argued that nicotine is a protectant, arguing that it reduces inflammation and that it actually interacts with the SARS-CoV-2 virus, which would inhibit it from entering your cells. They're still studying it. They haven't finished studying it yet, so technically we don't know. But the majority of evidence shows that nicotine in general potentiates cardiopulmonary disease, so heart and lung disease, and it also may enhance viral infection, which is something you don't want if you're trying to avoid severe disease, especially something like COVID-19. So since the data is majority says to avoid it because of health implications, some say no, it'll be okay. If we're not really sure about something, best practice is to just avoid it altogether until we know. Smoking generally contains nicotine. It is a pro-inflammatory action on your body, and it also is immunosuppressive. And it's kind of does two things: increases inflammation and also suppresses your immune system, which leads to immune dysregulation. This interrupts your immunological homeostasis. It upsets the balance, the fine balance that your immune system has in order to maintain appropriate levels and not attack yourself and not overreact, not underreact. It upsets that balance. Also, it is seen to promote autoimmunity. Things like autoimmune diseases and cancer can come as a result of smoking. Also, smokers tend to get sicker from infections. It also causes lung damage due to inhalation of smoke and the different carcinogens and the things in cigarettes. It causes lung damage, and that definitely does not put you in a good position if you are trying to fight against a respiratory virus. They also found that inflammatory markers seen in the cytokine storm, this is something they talk about in COVID-19, some of the more severe cases, they find those inflammatory markers, those same inflammatory markers are also elevated via smoking. So it sounds like it'd be something we would like to generally avoid. This slide was rather interesting. I just wanted to show you. You can see how nicotine impacts different cells of your immune system. Cigarette smoking alters the development of cytokine production and function of both innate immune cells and adaptive immune cells, and it leads to pro-inflammatory responses and dysfunction in the immune system overall. I did want to point out that smoking is an important cause of preventable death worldwide. It can lead to a lot of different autoimmune diseases and cancer, and is a major cause of COPD. And this graph here is just major diseases caused by cigarette smoking. So just for your information, there's a lot of different things, a lot of negative health effects besides suppressing your immune system, which is not what we want.
So there's some discussion about marijuana. Maybe this is anti-inflammatory, and this can help us modulate our immune system. And this might be have some medicinal qualities. There's been medical cannabis that's prescribed for people and things like that. It turns out that most of the data actually is usually done in fairly small studies and is, I'd say, insufficiently studied and to really support that cannabis has an anti-inflammatory effect that would help inflammatory diseases. In general, though, most of the way that cannabis is taken is by smoking, which is like cigarettes, going to be harming the immune function of the barrier, right? Your mucous membranes, the microbiome, and all of those things are basically affected in a negative way by inhalation and smoking. So that would not be a great thing. Vaping is another way of this, and vaping is a similar way, has lots of negative impacts on our lung, actually. It will not be a surprise that in 20 years or 30 years that for both cannabis and vaping, that there will be Surgeon General warnings appearing on those packages down the line, but that will have to take 20 or 30 years of learning and experience before the Surgeon General comes out with that remark for those things. Alcohol, let's talk a little bit about this. Alcohol definitely affects our immune system. Excessive alcohol consumption is linked to adverse effects related to immune function, both the innate and adaptive immunity. It's linked to increased risks of developing pneumonia and respiratory infections. There's disruption of the ciliary function in our upper respiratory tract, so that can impair the barrier function. And it also impairs immune cells and weakens the epithelial barrier in the lower. All right, some additional thoughts, though, about alcohol. It may be detrimental to immune cells due to the generation of free radicals during clearance. And so the idea is, well, if we have alcohol that is combined with antioxidants, and there are some, so that's been promoted with things like wine and things like that, because there's a good antioxidants in things like that. The Mayo Clinic, in some literature put out by them in 2019, said, keep in mind that even moderate alcohol use isn't risk-free. For example, even light drinkers, those who have no more than one drink a day, have a tiny but real increased risk of some cancers, such as esophageal cancer. And drinking and driving obviously isn't a great thing. That can impair us in ways. Eating a healthy diet and being active is a much greater way to gain the benefit that some of the antioxidant things that come from some alcohol containing beverages. You get all those antioxidants through a healthy diet, through, say, the pure juice of the vine, things like that. So
that's been more widely studied, so they know more solidly the health benefits of eating healthfully and exercise.
yeah, exactly. Okay, caffeine. So how does this impact the immune system? Is this an immune buster? So it actually does modulate the innate and adaptive immunity, although the studies and effects of caffeine are much like cannabis in that the studies are really small, not well shown, not well thought out. So there's not really a lot of evidence or strong evidence that caffeine is actually beneficial in modulating our immune system in a positive way. That's all I'm going to say about that. And remember, when you're ordering your caffeinated beverages, that sugar content is a big deal if you add it. And that is an immune buster that she's going to be covering soon.
Yep. So next we're going to talk about poor nutrition.
Oh man, M&Ms.
I know, these are all our comfort foods. These are our stress foods. That's what they are. Generally, when we think of poor nutrition, at least I do, I think of malnutrition, living off in a far enough country, not having access to lots of food, not eating enough calories. But you can have poor nutrition and still be eating a lot of food. You can be deficient in essential micronutrients and macronutrients that you're missing if you're eating the wrong kinds of foods. Generally, it's a little bit harder to do because a lot of the processed foods and things that are made nowadays are fortified. But a lot of the things that our body needs to live most healthfully and be optimized is found in lots of fruits and vegetables. And you can find those without it being added, they're naturally there. Hi. Were you going to say something?
I was going to say, if there's a reason that I can blame on why I got COVID, it would be because of this right here.
Oh, sugar.
It's my fault.
Okay. Well, high sugar diet. They're mainly talking about processed simple sugars. They found that this generally decreases phagocytosis, so it impairs the ability of your immune cells to engulf invading antigens. And it also increases inflammatory markers, which are cytokines in your blood. So it kind of has a pro-inflammatory effect as well as an immune suppressive effect. It also causes something called leaky gut, which we'll see a little bit more about later, but that generally not good for your health. They've done some studies in mice, and they find that high sugar diet is a risk factor for type 2 diabetes. And they also did a study with some flies, and they also confirmed that phagocytosis is impaired in high sugar diets, and that there is an activation of low grade inflammation. You kind of have a state of inflammation. Basically, sugar causes a low grade inflammatory state and an immune suppressive state.
I think all our flies should be on complex carbohydrates only.
And we'll talk more about complex carbohydrates and the benefits of good food in our next lecture, in lecture 4. Right now, we're just hitting on some of the negatives. So high sodium, there's not a lot of studies in this particularly. Some of the animal studies that they have done suggest an increase in the IL-17 mediated inflammation. Basically, it means you're going to be a more hyperinflammatory state. It can also possibly worsen autoimmune disease. This is inflammation related. Like we said, it's pro-inflammatory, which means you can be more susceptible to an excessive immune response. We talked about in the past that immunity is all about balance. You don't want to have too much, you don't want to have too little. There's just a perfect balance that you need to not damage yourself and to kill the invader. So too much is not good. Overreaction is not good. Moving on to a high fat diet. A high fat diet, just like the salt, it also has pro-inflammatory effects in your body, again through the same route as the sodium. It increases macrophage activation. They didn't really specify if this is a good or bad thing, but in a way, it's your macrophages are up. They did say it does disrupt your immune function and alters your lipids on the outside of your immune cells. So immune function is altered. It also directly triggers gut inflammation and reduces immune competence. So a normal, healthy immune system will be subpar on a high-fat diet. Just a quick slide on fats. In general, trans fats and saturated fats would be best to avoid or limit your intake of, and unsaturated fats are the more healthful, more health promoting. And trans fats are generally found in processed foods, things that come in a package. And then this was just an interesting slide just to see how different aspects of diet impact our body. So you see the salt increases IL-17, which causes gut inflammation. And you see the saturated fats do the same thing, as well as leading to dysbiosis, which is leaky gut. That's what sugar also does. And the little phytonutrients with the apple there, the little red line means it works antagonistically to dysbiosis. So it tries to prevent that. And those different processes put you more at risk for or cause systemic inflammation, susceptibility to allergies, increased risk for autoimmunity, and certain types of cancer, infection, and things of that nature. And so, like I mentioned before, a lot of the processed foods, things that are pre-made, things that come in packages, use caution. A lot of these foods are higher in sodium, higher in sugar, and higher in unhealthy fats. So just be careful about those. And eating out is just another place to be careful. Eat mindfully and think about what you're eating.
Being overweight, so unhealthy weight is a immune buster. So generally when we think of excess weight and disease, we think of diabetes, heart disease, high blood pressure, cholesterol, and other things. Recent studies in humans and animals show an impaired immune response in relationship to obesity, decreased cytokine productions, altered monocyte and lymphocyte functions, dysfunction of natural killer cells. So all of these markers and things, some of which we've mentioned before. The exact mechanism, exactly why that happens, what the association is not known. We think that maybe the excess adipose tissue leads to chronic inflammation, which makes it harder for the body to then fight off disease. There have been some human studies looking at this with altered immune cell function in overweight versus healthy weight. There has been accelerated we talked about the thymus and it kind of shrinking as we get older, becoming less functioning. And so that is accelerated when you're overweight. There's reduction in T cell diversity They've noticed that, and increased risk of infection overall. There's significant risk for post-operative surgical site and various infections also. We've noticed that. And there's also decrease in vaccine response. So decrease in vaccine response isn't necessarily related to the vaccine. It just means that when you're exposed to an antigen, however you're exposed, that's just one way for them to do it and to measure in a controlled way. But when you're exposed to an antigen, your body doesn't respond as well. They've done animal studies looking at diet-induced obese mice and have seen very similar types of things with them. And so this just basically is a visual showing, looking at body mass index and knowing that when we get a body mass index of 30 or more, the immune function is going to start to fall off. Type 2 diabetes is one of those diseases. It's definitely a lifestyle disease. And we know that with type 2 diabetes that there is definitely impaired immune function. The hyperglycemia, too much sugar in the blood, will affect how your immune system and all the different things, how the white cells and the phagocytosis and macrophages and all of that will underfunction, and you'll be more susceptible to disease. So both the innate immune response is defective, and also the adaptive immune response is also not as well. Short-term hyperglycemia can have an effect on our innate immunity too, so that puts us at risk.
I just want to make a comment. Because of the decrease in innate immunity, that's your first line of immune defense. So if that's already impaired, whatever is trying to come and invade your body has a greater chance of succeeding. And they found with COVID-19 in our last lecture, we just talked about how the virus already has mechanisms that kind of suppress and work around your innate immune system already. So having an innate immune system that's suppressed due to different factors is just another disadvantage and increase the risk for severe disease. Thankfully, type 2 diabetes is something that you don't have to live with forever. You can reverse it and decrease your risk through different lifestyle ways. All right, inadequate hydration. I didn't find any really studies about this and how this affects your immune system, but we're going to look at it from a physiology perspective. So based on what we talked about in our first lecture about the immune system function and structure and how it works, we'll just draw some conclusions. Once again, this isn't supported by any evidence per se. Inadequate hydration would seem that it would decrease and inhibit speed and smooth blood and lymph flow through your body. That would inhibit your immune cellular traveling throughout your body and doing good surveillance, as well as it would decrease your immune cell's ability to communicate properly and easily with one another, because if it's slow, then communication is slow. It would also seem to increase optimal function of mucosal membranes. Mucosal membranes, like we learned in the beginning, are mucousy and require hydration to be able to be wet and that would be to catch microbes and things like that. So if you're not adequately hydrated, there's more risk of that. Again, if you're not adequately hydrated, there might be impairment in circulation, which would decrease nutrient and oxygen delivery to cells, which is important in immune function and especially when fighting a battle against a virus or another invader. It would also inhibit waste elimination potentially. And hydration also plays a role in temperature regulation, which sweating and fever, we see that happen in the innate immune response. So it'd be important to be adequately hydrated so you don't deplete your hydration stores. So once again, that's based on physiology and speculative
application.
Yes.
All right, let's talk about sleep. Inadequate sleep. This is an immune buster. Was your immune system enhanced last night while you were preparing for this lecture?
This lecture wasn't quite as far as long as I was remembering it was. And so I was up very late / early in the morning trying to finish it. And my immune system is definitely impaired. The short-term effects of poor sleep, less than 6 hours, I'm feeling it today. So I can testify it's true.
Good sleep, we know, actually will replenish your immune cells during sleep, is a very important restorative phase for our body. And there's all kinds of amazing physiology and stuff that's actually going on during sleep. Peak immune fighting occurs during the night as well. So there's things that are specifically happening kind of tied to our circadian rhythms. Poor sleep will reduce activity of natural killer cells. Again, that's one of those biomarkers when they're looking at this question with various things. Prolonged sleep deprivation. There's been a lot of studies out there that have looked at this and its relationship to chronic inflammation and also immunity. There is a fairly significant, as I mentioned, relationship between circadian rhythms that our sleep is tied to and immunity. Prolonged sleep avoidance or losing a lot of sleep will lead to chronic low-grade inflammation. Our stress response will be up, the oxidative stressors will be up, the cytokine production will be up, and will impede our immune system. There's decreased neutrophilic function. There's delayed recovery and wound healing. So all of these markers and biomarkers that they measure, they're seeing with reduced prolonged reduction of sleep. So poor quality or lack of sleep increases our risk of getting sick after exposure to a virus. There's delayed recovery. There's decreased production of immune cytokines, and antibodies and infection-fighting cells are reduced with lack of sleep. Let's see, they've also looked at, again, with antigen exposure. The controlled way of doing that is giving someone a vaccine, but really you could do that with any antigen exposure. And they saw a much poorer, less robust response in developing an antibody response. And not only in just the immediate antibody response, but then the memory response as well.
I will mention that in most of the studies on sleep, when they're talking about sleep deprivation, they're talking and referring to not like a one-time thing, more like a habit of sleep that is less than 6 hours, less than 7 hours for sure. That's when they're seeing the negative effects when you sleep less than 7 hours. And they actually see like a U-shaped curve where, say, the negatives would be if you are less than 6 hours, and there would also be negatives if you're more than 8 hours. So that's a hint on what's coming next class period.
Oh, you mean you can get too much sleep?
Yeah, you can get too much sleep. Next class period, this is the one we've been hyping up. We're going to talk about the Restore Life acronyms and go through all the different ways these simple things that you can incorporate into your life, as well as eliminate things that are health inhibitors. But incorporating these things will do nothing but benefit your overall health, mentally, spiritually, and physically today and tomorrow. So we'll look at those in the next class period, and I'm super excited for that one.
So again, next class is immune boosters. Absolutely. Really good point. That was what I was supposed to mention during the inactivity one, because COVID promoted inactivity. If you're afraid to go out and do stuff, it didn't have to, but I'd say it would tend to. So I think your observation about all of those different factors were all the things that tended to happen as a result of, the changes during this pandemic. So good point. And you really have to be intentional to say, you know what, I'm going to go out and it's going to be safe. You can distance or whatever, but I'm going to get fresh air. I'm going to exercise. I'm going to do those things to, it would take a lot of intentionality.